Okay, example 2, write 3x plus y squared plus 7y minus 4 equals 0 in standard form, then find all that stuff, then graph the parabola. So, here's my equation right here. And again, I know immediately it's a parabola because y is squared and x isn't. Okay, and I want you to start recognizing structure of things in each chapter, because in chapter 8.3 we're going to do parabolas, ellipses, and hyperbolas all together. They're just going to throw this out. Graph this conic section and tell us everything you need to know. Tell us about it. You have to identify what kind it is based on its structure. So again, I know parabolas because one variable is squared, the other one isn't. That's always a parabola. Okay, and what I told you on the last problem was whatever is squared, that needs to be isolated from everything else. So y is squared, so everything y goes on one side, everything not y goes to the other side. So I'm going to keep y squared plus 7y on the left. I'm going to leave myself a little space, equals 3x minus 4, sorry, 3x plus 4, negative 3x plus 4. 3x moved, became negative, the 4 moved, became positive. The y squared and 7y stayed where they were, they stayed positive. One thing I'm going to remind you about, just in case it shows up, I don't think it does tonight, but just in case it does show up, you can't complete the square, which is what we're going to do next, unless it's 1y squared. If it isn't 1y squared, divide everything by whatever's in front of y. If it's like 5y squared, just divide everything by y. I don't care if it's 7/5, 3/5, and 4/5, that's better than having 5y squared. So 1y squared is your best friend, anything else y squared is not your best friend. So, going back to early Geo Trig, middle of the year, Algebra 2, we completed the square to solve quadratic equations. Completing the square is a technique that can be used in every one of these chapters. Chapter 8.1, 8.2, 8.3, completing the square. Completing the square involves this number, and we're going to take half of that number and square it. So, plus 7/2 squared completes the square. Since it doesn't divide evenly, I left it as a fraction. Alright? If you want to call it 3.5, you can. Again, we're graphing points, and maybe you like decimals better than fractions. It doesn't matter to me. Okay, I find fractions to be easier myself, so I'm going to keep it in fraction form. What do you guys prefer? Decimals, fractions? Anybody, does anybody care? All right. So I'm going to say plus 49/4. Now let me just make one mention of this because I've said it before in other classes, but it's been a while since you've heard it. Always plus. That one's always plus. This one might be minus, depending on what kind of modifications you have to make. As long as it's just 1y squared, it's always going to be plus on both of them. You add whatever you add to both sides. Alright, so as far as creating this standard form we're looking for this parentheses squared, right? So this right here is now a perfect square trinomial, which is going to be a parentheses squared, the square root of y squared, the square root of 7/2 squared, and the sign in the middle term. Okay, so factoring that perfect square trinomial. The outside objects, the y squared and 7/2 squared, are both perfect squares. The square roots just drop the squares. Drop the square, you get the square roots. And again, this is the only contributing factor for the middle term. Whatever that sign is goes right there. On the other side, we're supposed to add 4 and 49/4. 4 is the same as 16/4. Add 16 and 49/4, you're going to get 65/4. So these are both just regular numbers, so they just added together. And again, I'm creating this standard form, right? So the standard form with y squared is y minus k, the quantity squared, equals 4p parentheses x minus h. So there's your standard form for a y squared parabola. Does what I have look like that? Now what's messed up? The right side's messed up, right? They got a 3 in front of x. It's supposed to be some number times x minus another number, or even plus another. It doesn't matter plus or minus, but it's going to have that structure. So I want this to be parentheses x, okay? I don't want that minus 3, so minus 3 has to go out here. And the consequence is this becomes negative 65/12. Reason. We're taking 65/4, we're extracting a negative 3, which is division. So 65/4 is being multiplied by negative 1/3. which becomes 65/12, and it's negative because of the opposite signs. When you extract something, take a common denominator out, or a greatest common factor out, that's what you're doing, is dividing by it. This isn't really a greatest common factor, but it gets pulled out the same way you would pull out a greatest common factor. Because again, we're trying to create a structure. I just want x right there. That's my goal, just x right there. So whatever's in front of x has to be pulled out, and the consequence is the fraction gets divided by that, so multiplied by its reciprocal. And on this other side, we get y plus 7 halves the quantity squared. That's our standard form. So once we get to standard form, again, standard form gives us everything we need to know about this parabola. Okay, obviously, in this case, we know 4p is equal to negative 3, which means p is equal to negative 3/4 or negative 0.75. The fact that y is squared and x isn't gives me either left or right. Which one will it be? Be left because p is negative. Again, y squared tells me left or right, p's value tells me which one of the two it is. So it's left or right because it's y squared, it's left because p is negative. And as soon as I know it's left, I immediately know what it's going to look like, right? I'm going to have a vertical directrix, I'm going to have a vertex, focus, parabola goes like that. Yeah. Go based on the picture to establish where things belong, and then put them where they belong based on the numbers in the standard form. That's what my graph's supposed to look like. I just need to make it fit onto this graph paper now, right? Now, for the sake of making life easier, let's go decimal form on all these numbers. Y plus 3.5, the quantity squared, equals negative 3 parentheses x minus and 65/12. 65 divided by 12 is 5.42. Okay, 65/12 is about 5.42. 7 halves is 3.5. Feel free, a couple decimal places is plenty. We're graphing. If I can put 5.4166667, whatever it was, and you graph 5.42, they're the same. I mean, basically the same. So, the vertex is what?
0, 0?
No.
Negative 3/5.
The vertex is always these two numbers that are paired with the x and the y. X goes in front, y goes in the back, and it's minus in the formula, in the structure, so we change the sign. So h is 5.42 because it's minus that. So x coordinate of the vertex is 5.42. And y, it says y minus k, that's plus 3.5, so it's negative 3.5. So once you get that standard form created, the number paired with x, you change its sign. That's x. The number paired with y, you change its sign. That's the y. So if I plot my vertex, 1, 2, 3, 4, 5, almost a half, negative 1, negative 2, negative 3 and a half, there's my vertex right there. Okay, so I plot the vertex. Next thing I do is identify the focus and the directrix. The focus and directrix are based on p's value, and p's value is negative 0.75. I'm going to go 0.75 to the left to get the focus, 0.75 to the right to get the directrix, right? Because again, I know what it's supposed to look like. There's my parabola. Focus left, directrix right. I'm going p spaces left and p spaces right to get those things, right? So, does anybody know what a 5.42, if we subtract 0.75 from it, equals? Almost something, but if we don't know exactly, 5.42 minus 0.75 equals 4.67. 4.67 move horizontally, it's going to be about here. There's my focus. As far as identifying the focus is concerned, because I'm supposed to identify the focus, what coordinate changed, x or y? X. I moved from the vertex to the focus horizontally. So notice the focus coordinate, y coordinate is negative 3.5, because I didn't move up or down. I just moved left, and we figured out that's 4.67. How much is 0.75 bigger than 5.42? 5.42 plus 0.75 equals 6.17. So 6.17 is where the directrix is. So 1, 2, 3, 4, 5, 6, and a sixth, basically, there's my directrix. And again, I know my directrix looks like a vertical line, dashed, so I draw it that way. And identify its equation is x equals 6.17. Again, I'm basing everything on what it's supposed to look like and just putting things where they belong based on what it's supposed to look like. Finally, lattice rectum length is what? Lattice rectum length is always 4p, right? Absolute value of 4p. What is the absolute value of 4p in this problem?
Yeah, -4.75.
4p, just change that sign to a positive. The lattice rectum length is always just right there. Whatever that is, that's the lattice rectum length. Make it positive though. Length is always positive. If the lattice rectum length is 3, that means I need to go 1.5 spaces in both directions, right? Should I go up and down or left and right to get the points?
Up and down.
Very good, up and down. So if I'm at -3.5, 1/2, 1.5 right there, 1/2, 1.5 right there, those 2 points should be on my parabola. And that's all the lattice rectum length is ever going to do for me. That tells me how wide the parabola is at the focus. The focus is right here. I make it 3 wide. I go half as much up and half as much down to make 3 across. Then finally the axis of symmetry, if I'm graphing that, the axis of symmetry goes right through the vertex and the focus and is perpendicular to the directrix. So I just draw a line right there through the vertex and focus. It's a horizontal line. So the axis of symmetry equation in this case is going to be y equals a number. What number does it equal? How high is this line? -3.5, right? It's right where see the vertex and the focus, they share that number, -3.5. Y equals that number is the axis of symmetry equation. Final step is to draw our nice little parabola. Parabola goes through the 2 lattice rectum points along with the vertex. So again, we create the basic parabola here, then we just continue it on in both directions like so. Make a nice graphed parabola. Alright?
So for the directum, all you did was add the value of the first one minus the second?
For the directrix?
Yeah.
Yeah, so once I've established directrix goes to the right, I went 0.75 spaces to the right of the x-coordinate because I'm moving right. So the x-coordinate add 0.75. The x-coordinate subtract 0.75.
Okay.
So again, you're moving some direction left to right, you're changing x, up and down, you're changing y. So modify that coordinate of the vertex to get the numbers you need.